Hello, I'm Roshan recording experiment 3 Unix lab. Um, this question is about use of looping statements in shell scripting. The first question is to find the factorial of a number. Um, to find the factorial of a, let's see the code. So my code is inside yep, live factorial RSH. So this is my code. First I take one number as an input, then I store the number uh, in another variable I. Then later I have another variable named res that will have an end result, and it is 1. So inside a loop, what I do is um, I multiply mm, the input number which is copied into I into res, and each time I multiply I get a value in res, and then I decrease the value of I. So every iteration the value of I is like decreased by 1, that is using the that is this line at and in the next, like, let's say I want to find the factorial of 5. The first I entered 5. Now I first what it does is it multiplies 5 by 1, and now my res has 5. Then in the next input it will decrease the value of 5 by 1, that is 4, then multiply value of 4 by 5 and store 20 in res. Now it decrease again, it decreases the value of I by 1. Now I becomes 3, and multiply res with I, that is 3, then 20 into 3, that is 30. So and so and you can store the 23, that is 60, yeah. And so then you find the factorial of number. Let's see the output. If I was number, and yep, factorial of number 120, 5 is 120. Now the next question is find the sum of a given series. I use the series, the arithmetic progression, that is arithmetic series, as for the program. So let's see the code. Sum of series. This is my code. First I take first 3 values of the series, then I find the difference between the values using D and E. This is simply an evaluation to know if the series is an arithmetic progression. So if the difference between the first 2 numbers and the last 2 numbers are equal, then it is definitely an arithmetic progression. So if it is an arithmetic progression, then what I do is I'll ask how many you want to number, how many numbers. So once I read the number, get how many numbers, I use this formula to find the what is the nth number. To find the nth number, what you do is you add the first number to the product of the difference between the numbers, that is d, which you previously calculated, and n minus 1. So product of n minus 1 into d is added with the first value, so that we get the nth value, that is uh, yeah, the nth value. And using the nth value and the first value, uh, you can find the sum. So the formula is to multiply the number of how many the sum of how many number, that is n, into the sum of the first and the last uh, number, and divide the whole thing by 2, so you get the sum of the that many numbers of that series. So let's say let's run the code and see. Right here, first 3 numbers, I'm going to put 2, 5 and 8. All these numbers has a difference of 3, so it satisfies as an arithmetic progression. Now it's asking me what is the sum of up to how many numbers. So let's say up to 5 numbers, and sum of up to 5 numbers is 40. So that is the sum of 2, 5, 8 and 11 uh, and 14. So if you sum them, you get 40. So that's all. And then the next question is to find to display Fibonacci series. So let's see the code first. This is my code. First I ask how many you want to see, and I give the first in every Fibonacci series the first value is 0, the second is 1, and I'm displaying 0 first, then 1 first, and the third is also a 1. Now from the third number, uh, to find the next number, we add the previous two numbers. So first and second has the previous two numbers, and compute third by adding them. So once you display the third, now your first becomes second and second becomes the third. So it's like the first and second variables uh, takes the value of the value that is just ahead of them. So it keeps on moving, and it's to find the next value, it's just the sum of the previous two values. Let's see the code output. Yep, up to how many values? Let's say 5. And you get 0, 1, 2, 3, that is 0 plus 1, 1, 1 plus 1, 2, and 2 plus 1, 3. Uh, Now, the next question to find the multiplication table. Now, to display, let's see the code first. Multiplication table, that is MULT table data set. So this is my code. First, I ask them to enter the value to know, like for which they want the multiplication table to be displayed. Then I have I because I'm gonna display the multiplication table of from 1 to 15, like the number that is being input and its product with numbers from 1 to 15. So for what I do is I put them inside a while loop, and the numbers iterated from uh, 1 to 14. Okay, I display up to 30. So the result is the number, the n, that is the input into I, and if I changes, then I print the table. Now this is the expression where the value of I is incremented by one, like every loop. Let's see the code. So enter numbers, so let's say I enter 5, and this is the table, multiplication table of 5, that is product of 5 from the numbers 1 to 13 is, and see output. Now that is the multiplication table. The next question is to find the to the scientific calculator operation. My scientific calculator has 13 operations. So let's see the code calculator. So it can do addition, subtraction, division, multiplication, factorial, sine, cos, tan, square, modulus, square root, natural log, and log of base 10. It is actually first we display a menu, then we read the choice of the user. You use the choice interact switch case. So this is a case block. So this is a keyword case, and this is the value based on which we have to make the selection, and this is the different instances of choice, the different instances of values that choice may take. It may take 1, it may take 2, that is the choice that can be made. That is basically the index value of every option. So if it is 1, you perform addition. So every mathematical operation in shell programming is inside a tail symbol which starts with expr. So tilde expr dot a plus dot b returns a value, it's stored inside C, and we return C. Similarly, there is subtraction, division, multiplication. We had to use escape character because star alone has a different meaning inside a string. Uh, inside, not inside a string, inside a to the symbol. So tilde quote. So we use escape sequence character to give it the multiplication meaning. Then the next is a factorial. This is a small code to perform factorial. You need the value, then you increment from 1 to that particular value, and you keep multiplying 1 to a and storing the result back in a, and this keeps happening until the value of I becomes a, and then you display the factorial. To perform sine, we use the library called BC. BC is to use it's a code to use a library in Bash. It's to perform a complex mathematical function. First we read the degree, and we convert it to pi, and the pi value is converted to degree. In both these complex operations, we need to use BC. So we use a pipeline operator to include this library. Then once you have the radian, you use them inside the S function. This S function is to calculate sine, and same that it's the same case for cos. The only difference is you use a C function, that is to find the cos value, and to find the tan you compute the sine sine value and the cos value and divide it. So tan is all tan, as we all know, tan is sine by cos, so we can express the tan of some entered value. Then to find the square, I just multiply this number by the same number, and to find the modulus, we use a modulo operator. You can see the modulo operator here. Now later, to find the square root, we have another function called sqrt. Here also, since it's a complex mathematical function, you use the we include the BC library, and to find the natural log, we use the ln function. This is also an inbuilt function, and uh, we use L function. So L function actually, yeah, it finds some natural log. So if you want to find the log to the base 10, what we do is you find the natural log and divide it by the log value of 10, natural log value of 10, and you get the log to the base 10 value. And that is all the operations. Thank you.